Hello and welcome. In today's lesson, we're going to learn about inverse function. Now, I'm going to explain you what inverse function is and how to find the inverse function from an ordered pair, from a graph, and from an equation. So to start off, let's take a function f of x equals to, let's take a simple one, 2x plus 5. Now, this is a linear function, and we are using the function notation here. So we know that if we put an input, so let's say we put in 2, we should get 2 times 2 plus 5, which is going to be 4 plus 5 equals to 9. So we understand that when we put an input of 2, we get an output of 9. And again, if we put an input of 3, we get 2 times 3 plus 5 equals to 6 plus 5, which is going to be 11. Now, if we have to represent this using a mapping diagram, so let's take our domain, which are the values of x. So I can draw a domain using something like this. So let's take our domain. So in this case, we're going to just take two values. So let's take 2 and then let's take 3. And then our range would be again on this side. So that would be our range, and we have our output as 9 and 11. And we know that when the input is 2, we can map it onto 9 using this particular function f of x. And then when the input is 3, we can map it onto 11. So that's the basic that we have learned so far. Now this raises an interesting question, that is it possible for me to get the inverse of this? Is it possible for me to get some sort of function that when we put an input of 9 will give me an output of 2? Or we can say that when we put an input of 11, gives me an output of 3. So is the inverse possible? So we know that using this function, we can get 2 mapped onto 9 and 3 mapped onto 11. But is it possible to get the inverse? That is the basic concept of an inverse function. So we're going to learn how to find a function or other ways to find the inverse. To find when the output becomes the input, is it possible that the input becomes the output? I know this all is sounding a little confusing at the moment, but I'm going to show you, and I'm going to make it very, very simple for you guys. So we're going to start off with ordered pairs. How to find the inverse of an ordered pair. So we're going to go back to our first lesson where we learned what an ordered pair is. And we know that an ordered pair is a pair of numbers where we have an input and then we have an output. So let's take an example, and let's take the ordered pair 1, 2, where the x value is 1 and the y value is 2. Now, to find the inverse of an ordered pair, all you have to do is change the x to y and the y to x. So technically, we're going to have our inverse point to be 2, 1. Now, another important thing is how to denote an inverse function. So we have to remember that if we have a function f of x, the inverse is denoted. So technically the function notation of an inverse function is like this: f negative 1 x. Now this does not mean 1 over f of x. No, this is just a notation. Again, if we go back to our lesson for function notation, we learned that f of x is just a notation. It's just another way of writing y, the output, right? So if we have a function in the form of something like this, the inverse would be something like this, okay? And which does not mean 1 over y. This does not mean this. So let's go back. So this is how you find the inverse of an ordered pair. So if we have any number, any ordered pair, so let's say, let's take another one. Let's take -1, 5. The inverse would be the opposite, 5, -1. So we can generalize this and write it like this. So if we have any ordered pair in the form of x, y, the inverse would be y, x. Okay, so let's move on to find the inverse using graphs. I have a couple of graphs over here, and I'll just explain briefly. I'll just explain briefly how to find the inverse. Okay, now this is personally, I feel this is the hardest way to show the inverse, but there's nothing wrong in understanding the concept or knowing what it means using a graph. So using a graph, the inverse just means a reflection on y equals to x line. So if we have a graph of any function, and if we reflect that graph on the y equals to x, which is a straight line through the origin like this. So if this is my grid, this is my x-axis, this is my y-axis, the y equals to x line looks like this. It's a straight line through the origin, all right? So the inverse of any function using a graph would be the reflection on this y equals to x line. So I've shown two examples over here. So let's say our function is f of x, this one, and this is my line y equals to x. So if I reflect, if you guys can understand, this is a clear reflection, and we get our inverse function. And similarly, this one shows you more properly. You can see that we have a graph like this, and this is the line y equals to x, and it is reflected on this line to get the inverse graph. So I hope this is clear to you guys, and we're going to move on to the most important part of this inverse chapter or section. How to find an inverse from an equation. So let's go back to our function at the beginning. F of x equals to 2x plus 5. Was it plus 5? Let's take a look. Yeah, it was 5, plus 5. So let's look at this equation, 2x plus 5. So as we know that this is just written in using function notation, so we can write this function as y equals to 2x plus 5. Now, to find the inverse function of any function, just follow these steps. Number 1, interchange x and y. So if we have the function y equals to 2x plus 5, I'm just going to write it by interchanging the variables as x equals to 2y plus 5. And then the next step would be to solve for y. Now, after interchanging, you're going to solve for y. So we can say that we can take out the 5 from both sides. So we're going to end up having x minus 5 equals to 2y plus 5 minus 5. So that cancels out. And you're left with 2y equals to x minus 5. I'm just flipping the sides. Nothing changed really. I just brought one to the left and the other, and took the other one to the right. And then I can just divide both sides by 2. So let me do that. That's going to help me to cancel out these two. And then I'm left with y equals to x minus 5 divided by 2. Now that is my inverse function. And as I said, the notation for inverse function is this. So all you have to do is at the end change the notation. So the last step, I'm going to write it over here, is change the notation to y inverse. So now we can have our inverse function like this: x minus 5 divided by 2. That is our inverse function. Now, so what I'm going to do is I'm going to use this function, and I'm going to show that the example that we showed in the beginning, the inverse is also possible. So, so for the first one, what we did is we plugged in, so my f of x was 2x plus 5, and we plugged in 2 to get an output of, let's do this, 9. And so if my inverse function is correct, if I plug in 9, I should get 2. So let's try that out. So let's try the inverse function like that. Let's plug in 9 into the function, and we should get 9 minus 5 divided by 2, which is going to be 4 divided by 2, which is going to be 2. So that does give me 2. So this proves that this function can be noted as the inverse function of this one. So that's pretty much it. That's everything that you need to know about inverse function at this point of the course. And there could be more complicated functions for which you have to find the inverse, which we're going to learn later on or in some other course. But for now, this is everything that you need to know to master inverse function. So thank you so much. I hope you take the quiz and challenge yourself and answer the questions. This lecture is enough to answer the questions in the quiz. And good luck, and I'll see you in the next lesson.